let P be any point on its equatorial line, which set distance r from the center of diagonal. Obviously, what is field on this point at point P due to charge plus Q? Field at point P is, that is the unit head. Right. 1 over 4 pi epsilon naught Q upon, what is the distance by P? That is B square. Is it okay? B square. So E1 will be 1 upon 4 pi epsilon. It is R and base is A. Obviously it will be under root A square plus R square. So it will be under root A square plus R square. Its whole square. So E1 will be simply 1 upon 4 pi epsilon naught. Scalar root that field at point P due to charge plus Q. Just place it at point B. Is it okay? Same procedure to find the field at this point due to charge minus Q, which is placed at point A. What is it? If I 0, if I P2, it is simply, I'm just talking about magnitude, isn't it? So we should bother about this minus sign. It is 1 upon 4 by epsilon naught Q upon, how much is this point I get from A? That is P square. Isn't it?
Yes, sir.
So E2 will be simply 1 upon 4 by epsilon naught Q upon A square plus R square. First time you are saying about equation first and equation 2. You find E1 and E2 are of same magnitude, isn't it?
Yes, sir.
How I will calculate resultant field at this point, isn't it?
Yes, yes.
I will resolve E1 and E2 into rectangular components, isn't it?
Yes, yes.
I will resolve E1 and E2 into rectangular components. If you see, this is the E1 cos theta is the component of E1 along this way direction, and E1 sin theta is another component. Furthermore, if you resolve this E2 into components, you get this E1, E2 cos theta and E2 sin theta. Just have a look on this diagram. You see, sin theta component are both E1 and E2, they will cancel out because E1 and E2 are same magnitude. So what is the resultant field? Resultant field at point P. Resultant field at point P is, since E1 is equal to E2, they are same magnitude. So it will be simply E1. So what is field on equatorial line of the dipole? That is twice E1 cos of theta. So equatorial will be simply twice, just insert the value of theta, that is Q upon 4 pi epsilon naught A square plus cos theta into cos of theta. Now you have to determine the value of what is cos theta which is theta. So cos theta will be simply based upon hypotenuse. So cos theta will be simply based on this is simply OB upon PB. That is simply A upon A square plus root R square. Is it okay?
Yes, sir.
So you just insert this value here. So field on equatorial line of dipole will be, what is it? 2Q, just hits here. It is A square plus R square, isn't it?
Yes.
Its power is 1. Here its power is 1 upon 2. So 1 plus 1 upon 2 will be simply 3 upon 2. So what is the resultant field? E equatorial. That will be twice A cube 4 pi epsilon naught A square plus R square upon 3 by 2. Right? See here, what is dipole moment of this electric dipole? That is size of dipole into magnitude of either charge. That is simply 2AQ. So instead of 2AQ in the numerator, you just insert P. What is it? Dipole moment. So E equatorial will be simply P upon 4 pi epsilon naught A square plus R square. This expression for electric field due to dipole on this equatorial line. Now, I will apply here a special case where the size of dipole is very, very small, isn't it?
Yes,
Compared to the distance of the point from its center. So that is 2A is very, very less than R. If 2A is very, very less than R, then obviously A will be very, very less than R. You can neglect A square in the denominator of the equation. So what will the field on this equatorial line? That will be simply P upon 4 pi epsilon naught. It will here R square is power 3 by 2. 2 and 2 will cancel out. So E equatorial will be simply P upon 4 pi epsilon naught R cube. From this equation, you can say field due to electric dipole on this equatorial line varies as 1 upon R cube. Isn't it?
Yes, sir.
Since you are familiar with field due to a dipole on this axial line, what is it? That is twice P upon 4 pi epsilon axial upon equatorial. Is it okay?
Yes, sir.
It is simply 2.
Yes,
Because
sir.
this factor will cancel out. Twice P upon 4 pi epsilon naught R cube P upon 4 pi epsilon naught. So you can say the field due to dipole on its axial line is twice the field due to dipole on its equatorial line. So field is maximum on its axial line when compared to the field on its equatorial line. Is it okay?
Yes, sir.
Sure.